My name is Sonia from BSc Chemistry Honors second year. Today's topic is acid and the base. First one is Arrhenius concept of acid and the base. Arrhenius was the first to define acid and base in aqueous solution. According to Arrhenius, an acid is defined as a substance which contains hydrogen and which when dissolved in water gives hydrogen ion. All the mineral acid like HCl, HNO3, H2SO4 containing hydrogen when dissolved in water dissociate completely into the hydrogen ions. Arrhenius named this acid which dissociate completely in water as strong acids. There are other acids like acetic acid, carbonic acid and phosphoric acid which when dissolved in water do not dissociate completely into the ions. An equilibrium is set up between these ions and undissociated acid molecules. Arrhenius named this acid R as a weak acid. According to Arrhenius, a base is a substance which contains hydroxy group which when dissolved in water gives hydronium ions. Those substances like NaOH or KOH which when dissolved in water dissociate completely to hydroxide ions. Arrhenius named these bases which dissociate completely in water called strong bases. There are substances which do not completely dissociate into the hydroxide ions. Arrhenius named these substances as a weak base. For example, like ammonium hydroxide do not dissociate completely to hydroxide ions. Hydrogen ions obtained from acid and hydroxide ions obtained from base combine together to form an ionized water. Arrhenius described this combination of H positive or OH negative ions as neutralization. NaOH gives us Na positive plus OH negative. HCl gives H positive or Cl negative. Combining right hand side cancelling the common ion and on both sides the H positive plus of OH negative gives us water neutralization. Arrhenius concept is very simple to apply and explain a number of phenomena like neutralization, hydrolysis of salt, strength of acid and the base. There are certain limits which are described below. Arrhenius concept of acid and base is applicable only in aqueous solution. This concept fails to explain the acid and the base behavior of substance in non-aqueous medium such as liquid ammonia. Arrhenius concept failed to explain the acidic character of substance like SCO2, SO2, O3 and the basic character of substance like NH3, CO, etc. Arrhenius concept also failed to explain the reaction between an acid and the base in the absence of water. For example, ammonia react with HCl gives the ammonium chloride. Bronsted-Lowry concept. Arrhenius concept of acid and the base was further improved by the Bronsted or Lowry. Both Bronsted and Lowry introduced the same definition for acid and the base. According to Bronsted-Lowry concept, an acid is a substance which can donate a protons, whereas a base is a substance which can accept a proton, H positive. In other words, an acid is a proton donor whereas base is a proton acceptor. Lowry-Bronsted concept is sometimes called the proton donor acceptor concept. Acid gives us H positive plus of base. According to Bronsted-Lowry, a neutralization reaction involves the release of the protons by an acid and the absence of that proton by a base. For example, the reaction between the HCl and the ammonia to form salt and ammonium chloride can be represented as the covered arrow shows how electrons must rearrange to result in the transformer of hydrogen atom from acid to base. The unshared pair of electrons on the nitrogen of ammonia is attracted by the partially positive charge on the hydrogen in the polar hydrogen chloride molecules. A comparison of the structure of the reactant and the product shows that the hydrogen atoms which was bonded to chlorine in the reactant is bonded to nitrogen in the product. A product has been transferred from chlorine to the nitrogen, act as a Bronsted-Lowry base. In this case, the acid lose a protons and is an acid, and ammonia accept a protons from the acid. HCl is a base. It is important to note. In the above example, the water act as a base which respect to hydrochloric acid and sulfonic acid. Water act as acid with respect to ammonia. Now, such substances which can act both acid and the base called the amphoteric or the amphoteric substances. For similarly, bicarbonate ions behaves an acid and the base. Conjugate acid and conjugate acid base pair. Let us a reaction between the acid and the base. HCl plus of ammonia. HCl being an acid donate a proton from HCl ion, whereas ammonia being a base upset a proton and form ammonium ions. Now the chloride ions has tendency to accept the proton, whereas ammonium ions has a tendency to donate a proton. In other words, an acid donate a proton and becomes a base, and a base accept a protons becomes an acid. A base formed from an acid is regarded as the conjugate base of the acid. The acid formed from a base is called conjugate acid of the base. In the example above between HCl and the ammonia, Cl is a conjugate base of HCl, and ammonia NH4 positive is the conjugate acid of the ammonia. Acid and the base are related by the loss or gain of H positive, called the conjugate acid and base. It clearly indicates that any acid-base reaction would involve two acid and two base. This acid and base are called the conjugate pair. A substance is applicable of showing acidic character only if the other substance is capable of accepting the proton, that is base. For example, HCl is an acid in aqueous medium because water can accept the proton from HCl. HCl is not acid in benzene because benzene does not accept H positive ions from the HCl. Not only neutral molecules but contains cations and the anions may act as acid and the base. Both Arrhenius and the Bronsted-Lowry concept require an acid to be a source of protons. All the Arrhenius acid called the Bronsted-Lowry acid. According to Arrhenius, a base is a substance which gives OH negative ions in solution. NaH in the presence of water gives us Na positive plus OH negative. Whereas according to Bronsted-Lowry, a base is a substance which can accept a protons. For example, carbonate ions which accept H positive bicarbonate ions. Limitation of Bronsted concept. Although Bronsted-Lowry concept could explain the shortcoming of Arrhenius concept, yet it could not answer some of the well-established reaction. The reaction between the acidic oxide like CO2 SO2 with the base oxide like CaO MgO, which take place even in the absence of water. For the acidic nature of the compound like BF3 FeCl3 or AlCl3. Lewis concept of acid and the base. An acid is a substance which can accept a pair of electrons, and base is a substance which can donate a pair of electrons. In other words, an acid is an electrons pair acceptor. It means that a substance which has vacant orbitals to accommodate one or more pair of electrons act as Lewis acid. On the other hand, a base is an electrons pair donor. It means that any substance with unshared pair of electrons can behave as a Lewis base. Lewis base. The acid-base or neutralization reaction involves the formation of a coordinate bond between the electron pair donor or the electron pair acceptor. For example, the reaction between the boron trihalides and the ammonia Lewis acid. According to this concept, Lewis acid are classified as molecules having central atoms with incomplete octet of electrons, simple cations, and molecules in which the central atoms have available d orbitals and may acquire more than 8 electrons. Compounds such as AlCl3, SiF3 as a Lewis acid where the central atoms can explain its valence shell. Molecules with a multiple bond between atoms of dissimilar electronegativity. Carbon dioxide represent an interesting example of a double bond between the carbon and the more electronegative oxygen atom. Oxygen, more electronegative, has tendency to abstract the shared pair of electrons towards it. In CO2, it acquires positive charge on the carbon atoms, becomes deficiency, attaches with the oxygen of the hydroxide ions. Lewis base. According to this concept, Lewis base may be classified as one of the flowing type of substance. Negative charge anions. All the negatively charged species are Lewis base because they are rich of electrons and have a strong tendency to donate lone pair of electrons. Neutral molecules with one or more than one unshared pair of electrons, alkene and the alkyne with multiple bond, also form coordinate bond with the metals atom in organometallic compound. Acid and base reaction according to Lewis concept. Some of the typical acid and the base involves the formation of coordinate bond between Lewis acid and the Lewis base. Combination between the H positive and the ammonium. Combination of cupric ion with the ammonia. Lewis acid and the base concept discussed above is widely used because of its simplicity in understanding many acid and the base reaction in spite of its wider application than the Arrhenius Bronsted-Lowry concept. It is Lewis concept is to do journal and consider all the reaction forming a coordinate bond to the acid-base reaction. This is, however, not true always. According to Lewis concept, some of the transition metals that form compound with carbon monoxide such as nickel CO4. Formation of coordinate bond between the acid and the base is the base of Lewis concept. However, the well-known acid like HCl, HNO3, H2SO4 do not form any coordinate bond with the base such as NaOH, KOH. Accordingly, HCl, HNO3, H2SO4 should not be regarded as a acid according to Lewis concept. Lewis concept does not give any unit scale of acid and the base strength. Thank you.